NEC 440.14 specifically addresses the installation of disconnects for heating, ventilation, air conditioning, and refrigeration or HVAC and R equipment. It states that disconnects shall be readily accessible and within sight from the equipment. However, NEC 440.14 does not directly reference NEC 110. NEC 110 provides general requirements for electrical installations, including requirements for accessible and visible means of disconnecting equipment, specifically sections 110.24 and 110.26. Although NEC 440.14 does not directly reference NEC 110, it is generally accepted that NEC 110 applies to all electrical installations, including those covered by NEC 440. This means that the requirements of NEC 110.24 and 110.26 should also be met for HVAC and R equipment disconnects. NEC 110.24 defines readily accessible as capable of being reached quickly and without undue difficulty. NEC 110.26 defines within sight as within a distance where the equipment can be seen and can be readily reached from the position where the circuit or equipment is operated or serviced. Maintaining a 36-inch clearance around larger condensing units can be challenging, especially when factors such as local ordinances and setbacks are considered. However, it is important to ensure that disconnects are installed in a location that meets the requirements of both NEC 440.14 and NEC 110. In conclusion, NEC 440.14 and NEC 110 should be considered together when installing disconnects for HVAC and R equipment. Disconnects should be readily accessible, within sight from the equipment, and meet the general requirements of NEC 110 for accessible and visible means of disconnecting equipment. Let's delve deeper into each of these code sections and their practical implications. First, let's reiterate the core requirement of NEC 440.14 that the disconnect for HVAC and R equipment be readily accessible and within sight. This seemingly simple statement carries significant weight. Readily accessible means that the disconnect should be easily reachable without the need to climb over obstacles, move equipment, or use tools. It should be immediately available for operation in case of an emergency or for servicing the equipment. Within sight implies that the disconnect switch must be visible from the equipment it serves. The intention is to allow the person working on the equipment to visually verify if the power is disconnected, enhancing safety. Now let's consider NEC 110, which establishes general requirements for electrical installations. Section 110.24 specifically addresses access to working space around electrical equipment. It mandates sufficient access and working space for safe operation and maintenance of electrical equipment. This working space includes adequate headroom depth and width as defined by the NEC. Section 110.26 further elaborates on the required working space around electrical equipment operating at 600 volts, nominal or less. It specifies minimum clearances based on the voltage level and the presence of exposed live parts on one or both sides of the equipment. These clearances are essential to provide a safe working environment for electricians and other qualified personnel. The relationship between NEC 440.14 and NEC 110 becomes clear when we consider the overall intent of the NEC to ensure electrical safety. While NEC 440.14 focuses specifically on HVAC and R equipment disconnects, it does not operate in isolation. It is subject to the general requirements of NEC 110, including those pertaining to working space and accessibility. Therefore, when installing an HVAC and R disconnect, you must comply with both the specific requirements of NEC 440.14 and the general requirements of NEC 110. This means that the disconnect must be readily accessible, within sight of the equipment, and installed with adequate working space as defined by NEC 110.24 and 110.26. Consider a scenario where a large condensing unit is installed outdoors, adjacent to a building. The local ordinance requires an 8-foot setback from the property line, and the unit's dimensions further restrict the available space. In this situation, it may be challenging to maintain the required 36-inch clearance around the disconnect, as specified by NEC 110.26. However, it is crucial to find a solution that meets both the code requirements and the practical constraints of the installation. This may involve relocating the disconnect, modifying the equipment layout, or obtaining a variance from the local electrical inspector. In addition to the physical accessibility of the disconnect, it is also important to consider its visibility. The disconnect must be located so that it is clearly visible from the equipment it serves. This may require careful placement of the disconnect to avoid obstructions such as walls, fences, or landscaping. In some cases, it may be necessary to install multiple disconnects or use remote operating mechanisms to ensure visibility from all points where the equipment may be serviced. Furthermore, it is essential to ensure that the disconnect is properly labeled and identified. The labeling should clearly indicate the equipment that the disconnect serves, as well as the voltage and amperage ratings of the circuit. This will help prevent confusion and ensure that the correct disconnect is used when servicing the equipment. Now, let's discuss some common misconceptions regarding NEC 440.14 and NEC 110. One common misconception is that NEC 440.14 is the only code section that applies to HVAC and NAD disconnects. As we have already established, NEC 110 also plays a crucial role in ensuring the safety and accessibility of these disconnects. Another misconception is that the 36-inch clearance requirement of NEC 110.26 is absolute and cannot be modified. While it is generally advisable to maintain the specified clearances, there may be situations where it is not feasible due to site constraints. In such cases, it may be possible to obtain a variance from the local electrical inspector, provided that adequate safety measures are in place. These measures may include the use of insulated barriers, warning signs, or other protective devices. It is important to remember that the ultimate goal of the NEC is to ensure electrical safety. Therefore, any modifications to the code requirements must be carefully evaluated to ensure that they do not compromise the safety of personnel or equipment. Finally, let's address the question of enforcement. The enforcement of NEC 440.14 and NEC 110 is typically the responsibility of the local electrical inspector. The inspector will review the plans for the electrical installation and conduct on-site inspections to ensure compliance with the code. If violations are found, the inspector may issue a notice of violation and require corrective action. In some cases, the inspector may also impose penalties or fines for non-compliance. To avoid these issues, it is essential to work closely with the electrical inspector throughout the design and installation process. This will help ensure that the installation meets all applicable code requirements and that any potential problems are identified and resolved early on. Here's a more detailed breakdown of key aspects related to NEC 440.14 and NEC 110, along with practical considerations for installation. First, readily accessible versus accessible. The NEC distinguishes between accessible and readily accessible. Accessible means capable of being reached, but might require tools, the removal of obstacles, or the use of ladders. Readily accessible, as defined in NEC 100, means capable of being reached quickly for operation, renewal, or inspections, without requiring those actions. For HVAC and NAD disconnects, readily accessible is the requirement, emphasizing immediate access for safety and maintenance. Second, within-site requirements. The within-site requirement in NEC 440.14 mandates that the disconnect switch is visible from the HVAC and NAD equipment. This ensures that anyone working on the equipment can visually confirm that it is energized. The NEC doesn't specify an exact distance for within sight, but it's generally interpreted as being within 50 feet and visible without obstructions. Third, working space and clearances. NEC 110.26 specifies minimum working space clearances around electrical equipment operating at 600 volts or less. These clearances ensure that electricians have enough room to safely work on the equipment while it is energized or de-energized. The required depth of the working space varies based on the voltage and the conditions on the opposite side of the equipment. Condition 1 involves exposed live parts on one side and grounded parts on the other side. Condition 2 involves exposed live parts on one side and insulated parts on the other side. And condition 3 involves exposed live parts on both sides. Fourth, disconnect types and ratings. The disconnect switch must be suitable for the voltage and current rating of the HVAC and our equipment. It should be horsepower rated if it's used to disconnect a motor. Common types of disconnects include fused disconnects, non-fused disconnects, and circuit breakers. Fused disconnects provide overcurrent protection in addition to disconnecting means. Fifth, labeling and identification. Proper labeling is crucial for identifying disconnects. Each disconnect should be clearly labeled to indicate the equipment it serves. The label should be durable and easily readable. Use permanent marking methods to prevent labels from fading or deteriorating. Sixth, local amendments and interpretations. Local jurisdictions may have amendments to the NEC or specific interpretations of the code requirements. Always check with the local electrical inspector or building department to ensure compliance with local regulations. Local amendments may address specific environmental conditions, such as coastal areas with increased corrosion risks. Seventh, coordination with other trades. Coordinate with other trades such as HVAC contractors and building contractors to ensure that the disconnect location is accessible and meets all code requirements. Early coordination can prevent conflicts and ensure a smooth installation process. Consider the placement of ductwork, piping, and other equipment when determining the disconnect location. Eighth, practical installation tips. Choose a disconnect location that is readily accessible and within sight of the HVAC and our equipment. Ensure that the disconnect is mounted securely and protected from physical damage. Use appropriate wiring methods and connectors for the installation. Provide adequate support for the disconnect enclosure and conduit runs. Ninth, common violations and how to avoid them. One common violation is obstructed access to the disconnect. Avoid placing the disconnect behind equipment, in locked rooms, or in areas with limited headroom. Another common violation is inadequate working space around the disconnect. Ensure that the required clearances are maintained and that there are no obstructions in the working space. Improper labeling is also a frequent violation. Clearly label each disconnect to identify the equipment it serves. 10th, special considerations for large equipment. For large HVAC and our equipment, such as chillers or large air handling units, multiple disconnects may be required. Coordinate with the equipment manufacturer and electrical engineer to determine the appropriate number and location of disconnects. Ensure that each disconnect is properly sized and rated for the equipment it serves. 11th, maintenance and inspection. Regularly inspect disconnects to ensure that they are in good working condition. Check for signs of corrosion, damage, or overheating. Test the disconnect to verify that it properly energizes the equipment. Replace any damaged or defective disconnects immediately. 12th, documentation. Keep accurate records of all electrical installations, including disconnect locations, wiring diagrams, and equipment specifications. This documentation can be helpful for future maintenance and troubleshooting. Provide a copy of the documentation to the building owner or facility manager. 13th, training and qualifications. Ensure that all personnel involved in the installation, maintenance, and inspection of electrical equipment are properly trained and qualified. Electrical work should only be performed by licensed electricians or qualified individuals under their supervision. Provide ongoing training to keep personnel up to date on the latest code requirements and best practices. 14th, variances and interpretations. If you encounter a situation where it is difficult to comply with the code requirements, consult with the local electrical inspector to discuss possible variances or alternative interpretations. Be prepared to provide documentation and justification for any proposed changes to the code requirements. Obtain written approval from the electrical inspector before proceeding with any non-compliant installations. Finally, staying updated with code changes. The NEC is updated every 3 years, so it is important to stay informed of any changes to the code requirements. Attend training seminars, read industry publications, and consult with electrical experts to stay up to date on the latest code developments. Implement a system for tracking code changes and communicating them to all relevant personnel. Let's delve into more specific scenarios and considerations related to NEC 440.14 and NEC 110. First, multi-tenant buildings. In multi-tenant buildings, HVAC equipment may serve individual tenant spaces or common areas. Ensure that disconnects are accessible to the appropriate personnel, such as building maintenance staff or individual tenants. Consider using lockable disconnects to prevent unauthorized access. Clearly label disconnects to indicate which tenant space or common area they serve. Second, rooftop installations. Rooftop installations of HVAC equipment present unique challenges for disconnect accessibility. Ensure that there is a safe and accessible pathway to the disconnect, such as a permanent ladder or stairway. Provide a clear and unobstructed working space around the disconnect. Consider using weatherproof disconnect enclosures to protect against the elements. Third, emergency situations. In emergency situations such as fires or floods, it is crucial to be able to quickly de-energize HVAC equipment. Ensure that disconnects are readily accessible to emergency responders. Consider installing remote shutdown switches in strategic locations. Clearly mark disconnect locations with reflective signage. Fourth, accessibility for persons with disabilities. The Americans with Disabilities Act, or ADA, requires that electrical equipment be accessible to persons with disabilities. Ensure that disconnects are mounted at a height that is accessible to wheelchair users. Provide adequate maneuvering space around the disconnect. Use controls that are easy to operate with one hand. Fifth, voltage drop considerations. When installing disconnects, consider the potential for voltage drop in the circuit. Excessive voltage drop can cause equipment malfunction and reduce performance. Use appropriately sized conductors to minimize voltage drop. Consider using a separate disconnect for each piece of equipment to reduce the load on each circuit. Sixth, surge protection. HVAC equipment is susceptible to damage from voltage surges caused by lightning or other electrical disturbances. Consider installing surge protection devices at the disconnect to protect the equipment. Choose surge protection devices that are specifically rated for HVAC equipment. Follow the manufacturer's instructions for installation and maintenance. Seventh, energy efficiency. When selecting disconnects, consider energy efficiency. Look for disconnects that have lower resistance and minimal energy loss. Consider using solid-state disconnects, which have lower energy losses than traditional mechanical disconnects. Implement a regular maintenance program to ensure that disconnects are operating efficiently. Eighth, environmental considerations. Consider the environmental impact of disconnects. Choose disconnects that are made from environmentally friendly materials. Dispose of all disconnects properly to minimize their impact on the environment. Implement a recycling program for disconnects and other electrical equipment. Ninth, coordination with utility companies. When installing disconnects for large HVAC systems, coordinate with the local utility company. The utility company may have specific requirements for disconnect location and accessibility. Obtain approval from the utility company before proceeding with the installation. 10th, future expansion. When designing an electrical system for HVAC equipment, consider the potential for future expansion. Provide adequate space for additional disconnects and other electrical equipment. Use modular disconnect systems that can be easily expanded as needed. Document the location and specifications of all disconnects for future reference. 11th, temporary installations. For temporary HVAC installations, such as those used during construction or renovation, ensure that disconnects are installed in accordance with the NEC. Use temporary wiring methods that are safe and compliant with the code. Provide adequate protection for disconnects and wiring to prevent damage or injury. 12th, hazardous locations. In hazardous locations, such as those containing flammable gases or vapors, special precautions must be taken when installing disconnects. Use disconnects that are specifically rated for hazardous locations. Follow all applicable codes and standards for hazardous location installations. Implement a regular inspection and maintenance program to ensure that disconnects are operating safely. 13th, arc flash hazard. Arc flash is a dangerous electrical hazard that can cause serious injury or death. When working on or near electrical equipment, including disconnects, take appropriate precautions to protect against arc flash. Wear appropriate personal protective equipment, or PPE, such as arc-rated clothing and face shields. Follow safe work practices, such as the energizing equipment before working on it. Conduct an arc flash hazard analysis to determine the potential arc flash hazard level and select appropriate PPE. 14th, remote monitoring and control. Consider using remote monitoring and control systems for HVAC disconnects. These systems allow you to monitor the status of disconnects from a remote location. You can also use these systems to remotely control disconnects, such as turning them on or off. Remote monitoring and control systems can improve energy efficiency, reduce maintenance costs, and enhance safety. In coastal areas of Florida, additional considerations are necessary. Saltwater and humidity can accelerate corrosion of electrical equipment, including disconnects. Use disconnects that are specifically rated for coastal environments. These disconnects are typically made from corrosion-resistant materials, such as stainless steel or aluminum. Apply a corrosion-resistant coating to all electrical connections. Inspect disconnects regularly for signs of corrosion and replace them as needed. Consider using sealed disconnect enclosures to protect against moisture and salt spray. In summary, complying with NEC 440.14 and NEC 110 requires careful attention to detail and a thorough understanding of the code requirements. By following these guidelines and working closely with electrical inspectors and other qualified professionals, you can ensure that HVAC and R disconnects are installed safely and in accordance with all applicable codes and standards.